the
This
road.
conference will now be recorded.
All right, well, good morning, good afternoon, good evening to wherever you are in the world, and welcome to Cloud City. I hope you guys are all doing well today. And we're just going to start with some introductions. My name is Hin Tang, and I've been working with Veeam products for a little over 10 years. I started off at a company that was looking for a solution to back up our Hyper-V environment. So I was one of the rare people that actually started off on that side of the virtualization world. And I've had, since then, I've moved and had some experience on the service provider side. And now I'm working at a VASP, which is supporting other service providers. And I mean, my cloud journey is relatively new, but I'm super excited to be a fellow traveler with all of you on this Veeam for Cloud learning journey. And Michael, would you like to introduce yourself?
Okay, so yeah, I'm Michael Paul. I'm a data protection consultant by day and the other Cloud City leader by day and night. I've been working with Veeam Technologies for over a decade now, and the cloud for not long off a decade either. My experience of the cloud lies more within the realms of Microsoft Azure and Microsoft 365, with some Google Cloud Platform experience too. But enough about ourselves. We're here today to discuss a little project we've been working on for a while. So, would you say, Hin? Should we get into it?
Absolutely, let's do it. Okay, so basically this Veeam user group exists to provide a centralized location to discuss Veeam's public cloud and SaaS solutions, namely the Microsoft 365 product, AWS, Azure, GCP, and Salesforce. Basically, we want to facilitate a discussion around our successes and struggles with these Veeam products so we can all learn how to best protect the data within the cloud. So let's expand on this. So first of all, we want this group to be an open and welcoming space to answer questions, initiate discussion. I believe that everyone is somewhere on the learning journey. Everyone has something they can teach, and everyone has something they can learn. And also, I believe that there are often many paths to the same summit. So I hope that this group will be a place where we can respectfully share and discuss what we've been learning. And secondly, we also want to be a bridge. We want to bridge the gap between Veeam's traditional product portfolio and the resources within their cloud and SaaS offerings. We find there's a lot of overlap between the products, especially in some of the bridging and monitoring management products like the Veeam Service Provider console, as well as Veeam One and the Recovery Orchestrator. All right, so the next slide, we're going to talk about what will this group discuss. And basically, again, the idea for this group came from the fact that Michael and I both kind of saw that the Veeam Cloud portfolio is different than the traditional product portfolio, both in the way it looks and I guess the way it's implemented. And then even then within the big three public cloud providers, there's a lot of differences in the way that cloud is implemented, and also the way that the Veeam products protect those environments. So we found that we feel that there's a lot of discussion here that's going to be distinct and different from the traditional portfolio. As some examples with the cloud, we have to talk about IAM permissions and roles, the whole concept of regions, how to manage different accounts, even things like private and public subnets and networking in general is slightly different within the public clouds. So that's kind of what we're hoping that will be discussed in the Cloud City in the user group. What do you think, Michael?
Yeah, so just to bring that point home, I mean, primarily, we are going to be discussing the Veeam products that fall within the public cloud and SaaS categories. So These are currently Veeam Backup for Microsoft 365, Veeam Backup for Salesforce, and Veeam Backup for Public Cloud, which are Veeam's offerings for AWS, GCP, and Azure. But we do understand that there are always elements of overlap. This includes, as you mentioned earlier, the Veeam Service Provider Console and the Recovery Orchestrator. Now, the Veeam Service Provider Console, that might be due to the integrations that now exist between some of those previously mentioned Veeam products. And with Veeam Recovery Orchestrator in this latest release, we've seen the support for cloud plans as a new recovery location. So as these different bridges, as you mentioned, are starting to be built, we want to make sure that we're a good place to talk about it. But away from products for a moment, let's also talk about, in general, we understand that content isn't always going to be directly related to Veeam backup products. And even if it's not, there might still be a benefit for us as a community. So myself and him, we've prepared a non-exhaustive list of examples, and I'll just kind of talk through these. Hopefully everyone can understand the spirit of what we're trying to achieve as a community. So starting with how-to guides, this could be your typical setting up Veeam products. This could be specific features or working with related technologies, such as creating object storage buckets for Veeam backup product use. And this feeds into general learning resources such as Veeam or third-party training related to these products. And then with regards to experiences being shared and lessons being learned, this is a deliberately broad term because when working with these technologies, you are going to have your own needs, you're going to have your own constraints, and we encourage you, please share with us what they were and how you're utilizing Veeam to meet those. The most obvious example I can think of changes to cloud or SaaS platforms that impact data protection that I can personally think of is when Microsoft introduced the Teams API and announced they'd be disabling access to Teams data for exchange. And worst of all, it was going to be metered. This had clear cost, complexity, and design considerations to Veeam products. So even though the Teams API was nothing to do with a Veeam announcement, a Veeam product change, we definitely should be talking about it in the Cloud City because it has such a key impact to the products that we're working with. Taking a step back from, kind of cloud and SaaS exclusivity, a conversation that Hin and I previously held was around that knowledge gap of cloud and data center. If you didn't know how to provision object storage and you asked a cloud consultant to create some object storage for you, they'd ask you how you want the object storage. And something I see all the time is this knowledge gap where they say, okay, well, how do you want the object storage? What do you say to them at that point? Well, you want your object storage to be large and full of objects. But the point is it's an open question and that requires expertise to answer. So we are expecting a natural amount of overlap where somebody might be trying to use Veeam Recovery Orchestrator for cloud plans, for example. Any of these scenarios, it is welcome here. And of course, help. If you need help or if you believe you can help, absolutely get involved. Just to really bring the point home that he mentioned earlier, we are all on this learning journey together, after all. But these are just some examples. So to echo back what I said at the beginning, it's a non-exhaustive list. If you truly believe that it belongs in the Cloud City Veeam user group, it probably does. And if not, then we'll do our best to find a suitable home for it. And just so we've touched on it, there are some things that absolutely won't be welcome in the group. In addition to the normal housekeeping rules of the community, and again, something that Hin you touched on earlier, this needs to be a friendly open space. We just want to call out that look, this group isn't a replacement for the Veeam R&D forums, so keep your feature requests going to those forums. And likewise, any talk about the cloud or SaaS that has no basis around or impact to data protection shouldn't be posted in this group. If you've used OpenAI to generate PowerShell scripts for some cool backup integration functionality, then great, please share it. But if you want to talk about building an OpenAI instance, then we're not really the ideal place for that conversation, just as an example. So the ground rules are set, and let's talk about our plans for Veeam user group sessions. So back over to you, Hin.
I had muted myself, sorry. I've got some background noise here. As you can see, I've got gerbils and they're making a lot of noise. So anyway, thanks, Michael. So we are a thematic group and not a geographically located group, and that brings some challenges. One of the things is that we unfortunately probably will not be able to meet in person. And also, in addition, the scheduled sessions that we're going to have might not be at an ideal time for everyone, but they will be recorded. And you know, Michael and I both expect that there's going to be a lot of lively discussion before and after the events. So currently, our plan is to have 2 VUG Cloud City sessions per year. If we kind of consider this one as our first for 2023, we have a plan to do another one in the second half of this year. And so this leads us to ask you, as the Cloud City community, to share with us what you'd like to hear about. This is a totally open group, so we want to hear what you know, what inspires you guys, what you guys want to hear about. We want to hear about experiences from the field, or if there's some specific challenges or specific cloud topics that you've been really digging into. Those are the kind of things that we'd like to hear. And we kind of feel like within the group, there's going to be a lot of discussion. People will bring up topics, they might lead into other topics, and it'll be a very organic, collaborative growth of these ideas. And then we'll kind of distill all the best ones, or what we feel would benefit the community the most, into plans for the specific session and the presentations that we'll have there. And again, we're looking forward to 2024 as well. So you know, put your ideas out there. If there's anything that you've been thinking about, any ideas that have been floating around in your head, put them out on there in the group, and we'll start discussions will start around those topics. So as an example, like for example, for me, like the Veeam Salesforce is the newest product, and I'm really curious to see if there's people out there that have been using it, and you know, how it compares to other solutions that have been out there, if it has any limitations or, you know, strengths. Those are the kind of things that, you know, we're really hoping that this group will initiate, will be kind of a catalyst for further discussion. So so now, speaking of presentations, Michael, I believe you have prepared something for us.
That's right, Hin. So everyone, I'm going to bore you to death with PowerPoint slides. Hopefully not. I've prepared a little session about backup copies and geo-redundant object storage. And what I've been finding is that there's been some oversimplification in the way people have started to consume object storage, and I believe that it's starting to make organizations accidentally put their data at risk. So I wanted to do a bit of a comparison of backup copies versus geo-redundant object storage, where they're similar, where they differ. And in this session, you know, I'll explain these potentially overlooked risks and share some design considerations I've been applying to my backup architectures. I hope you'll find it useful, and please fire over any questions as we go, and I'll go through them at the end of the session if there are any. So let's start with, you know, let's ask the question, what is a backup copy? And then secondly, what makes a backup copy good? In other words, what makes a particular backup copy useful to our organization? Well, firstly, a backup copy should be distinct. We don't want the backup to have dependencies on another backup's existence. You know, if we consider RAID storage, if I have multiple disks with identical copies of data, are these backup copies? Well, no, because they are synchronous writes of the same data and vulnerable to the same corruptions or deletions. You know, what is applied to one disk's copy of data is applied to all. Instead, we would want completely separate media. But next, a good backup copy should be a strategically designed backup. So this means that whatever fault or issue we're trying to protect ourselves against with a backup copy. So if I evolve that previous example, if I split a RAID into 2 separate disks and sort of backup copy on each, how is this effectively meeting the needs of my business? assuming they're still in the same server. If I think of, the 3-2-1-1 rule, we should have, and please remember these are minimums, we should have 3 copies of data, including our production copy. They should be across 2 media types. This would be tape or discs as examples. 1 copy should be offsite, and 1 copy should be immutable or air-gapped. So if I split this RAID in 2, it only helps me have an extra copy of data, but it doesn't provide any additional protection for a scenario other than device failure or the failure of other backups and production data. It's not an efficient utilization of our backups. Instead, if we took one of those disks, we acquired another backup server within another geolocation and stored an independent copy of our backups there, well, then we've met the off-site objective for our data from that 3-2-1-1. And that's then improving our chances of recoverability in the event of a disaster. So this is where geo redundancy starts to blur the lines. On the surface, it sounds like a great idea. A cloud provider automatically providing an additional data copy within another location for us. But there is more going on than that at first appearance. And that's what I want to explore with you further. As there are so many possible S3 compatible solutions and configurations, let's just look at some of the common ground between the hyperscale object storage providers. Firstly, did you know that geo-redundant data is asynchronously written? This means that when you're choosing to save your data within multiple regions, any writes or puts, as they're called, they are sent to your object storage, and your object storage will confirm them once they've been written to the primary region, with backend processing making these copies available at the secondary region at another point in the future, which we will explore in a bit more detail later. And this creates a key problem with application awareness, because if Veeam doesn't have visibility into the back-end life cycles of this data, then how can Veeam be aware of any delays in the writes or failures of synchronization? If we consider a scenario whereby you've updated your metadata and uploaded 100,000 new objects, and the metadata has updated to your secondary region, but you're still missing 50,000 objects, how could Veeam reliably restore data from that region when half of the new objects don't exist? And this brings us onto the topic of service level agreements, or SLAs as they're commonly referred to. All too often, there isn't a specifically defined time that the data must be copied within. These SLAs can help eliminate some worries about the lack of application awareness as it becomes an assured service. So we can make some reasonable assumptions, at least, as to how swiftly the data will be available within another region. We're now going to explore some of these specific hyperscale object storage offerings, and let's just start off with what they're called. Within AWS, we have their S3 CRR service. Azure have their blob storage with GRS redundancy, and GCP has DR and MR cloud storage. Don't worry about that wall of acronyms I just said to you there. We're going to explore them as they become relevant. So if we kick things off with AWS S3, on the surface, you might be thinking about AWS being geo-redundant by default, as the standard S3, infrequent access, and Glacier storage classes on S3 all copy their data across at least 3 availability zones. But those availability zones are all stored within the same region. AWS just provide assurances that the individual data center zones these copies reside within are, at least in their words, miles apart from each other. That's great for protecting against fire or flood damage to a localized region, but it's not truly geo-redundant. For true geo-redundancy, you have to invest in AWS's cross-region replication. So AWS cross-region replication, or AWS CRR, as the acronym was, is the only one I'm going to focus on, because whilst AWS also offers batch replication, this isn't an automated replication task, and instead it is on demand. AWS cross-region has 2 replication techniques. The default replication is best efforts for their timing that they give, but AWS also offers an additional service called S3 replication time control, or to really overwhelm us with acronyms, S3 RTC. This allows you to assure that 99.99% of your objects are replicated in seconds and no more than a maximum of 15 minutes. Again, for 99.99% of the objects. But that is backed by financial SLA, and that can dramatically reduce the RPO for a regional level disaster. But as you can imagine, it involves an extra cost. So did you also know that if you're using object lock or versioning, which you're probably going to want to be using for immutability, these configurations must be identical between your two buckets. Otherwise, you can't configure replication between them. And did you also know that cross-region replication can target many destination buckets from one source? That is a feature I think is really cool with AWS, that if you wanted to have more than just two different regions, you want to go for free, you don't need to create additional backup jobs for it. You could specify, here's my source replication target, local to my Veeam servers or services for the maximum performance, and then replicate it out in the back end. And finally, did you know that this replication doesn't give you a global endpoint name that is used automatically for failover? Instead, you need to use a multi-region access point for this, where you can specify your active and passive S3 buckets. Otherwise, it's down to you to target your S3 regions individually when you need to utilize a secondary region. So that's S3. Now let's take a look at how Azure Storage tackles geo-redundant storage. Microsoft offer 6 different redundancy options for data within Azure Storage. But before we get into those, I want to talk about Microsoft data center concepts. Microsoft allow their customers to create their resources within a region, and a region is made up of 3 availability zones, all with separate cooling, networking, and power feeds, and they have a mandated minimum distance between each other to protect against shared fault domains between these different zones in a region. And the reason I mention this is due to the options that Microsoft offer. Microsoft's lowest redundancy tier is called locally redundant storage, aka LRS, whereby Microsoft will store 3 copies of your data synchronously within a single zone within a region. As the writes are synchronous, Microsoft doesn't return a success output until all 3 copies are successfully written. The fault tolerance that Microsoft are offering within locally redundant storage is protection from localized rack level failures, for example. Then Microsoft take it up a notch and they offer zone redundant storage, which is similar to what we just saw with AWS's S3 availability zones, whereby Microsoft will create the same 3 copies of data, but rather than all 3 copies being located within the same zone, Microsoft will store 1 copy per zone, ensuring that should an entire zone fail, again, via flood, you'll still have access to your data. Writes are still synchronous between these 3 zones, and Microsoft still won't return a success output until all 3 copies of data have been successfully written. Beyond these 2 is where things start to become more interesting. Microsoft offer a geo-redundant storage option, unoriginally named geo-redundant storage, often abbreviated to GRS. Now, GRS gives you double the amount of copies as LRS or ZRS, as it will store 3 copies of data per region. But within each region, GRS is behaving the same as LRS. It's storing 3 copies within the same zone per region. Furthermore, Microsoft will provide a successful write output when data has been committed successfully to the primary region, and then we'll asynchronously copy this data to a predefined secondary region as a backup process. Now, accessing the data within the secondary region can require additional steps. If you had an issue with accessing the LRS copies within the primary region, you won't transparently transition to using the secondary region. You have to initiate a storage account failure to enable this behavior. And this is where things get really interesting. When you enable a storage account failure, you're actually converting your storage account from GRS to LRS, with the secondary region becoming your only region for the storage account. This means that all of your data within the primary region is considered lost. So you can't test this in advance without losing all of your primary region data. To restore GRS functionality, you'd need to configure GRS again and accept the time and cost for all of your data to be replicated across to your other region again. This is an important RTO consideration here, as the time to fail over a storage account typically takes an hour in the first place, but this doesn't have an SLA defined against it. To counter this somewhat, to enable restores, you could use RA GLS, which is read access enabled GRS. This way you'd be able to perform reads against your secondary region, which negates the RTO consideration I just mentioned for restores, but you'd still require a storage account failover before you could take any new backups. Above and beyond this, Microsoft offered Geo Zone Redundant Storage, aka GZRS. I'm going to speak a bit harshly about this product, as this sounds like the flagship product, but it's not quite. If you use GZRS, then you get the ZRS level data protection, which, as a reminder, because we're so swamped with acronyms, ZRS was our zone redundant storage, where we have a copy of data between each of the 3 zones within a region. Microsoft will do ZRS, but only within our primary region. The secondary region will still be LRS, aka all of the secondary region copies will exist within one zone within that secondary region. And the same restrictions with regards to the storage account failover exist for this redundancy tier as well. And finally, Microsoft still support a read access version of GZRS called RA-GZRS. And this enables reads from the secondary region without initiating the storage account failover. Now, I appreciate that was a lot of information to take in with regards to Azure storage. So let's boil this down and get some extra insights into some of the key did you knows. So firstly, did you know that Geo Redundant Storage doesn't have an SLA for data replication between regions? Microsoft state it's typically less than 15 minutes, but they offer no guarantees to that number, financially backed or otherwise. Did you know that accessing the secondary region's data can require extra steps, as it can also break your geo redundancy? To expand further on my point earlier regarding GRS, should you fail over to a secondary region due to an issue, and then re-establish the conversion of your secondary region's LRS copy back to GRS, we get our copy back in the primary region. If you want to fail back to using your primary region as a primary region again, you have no choice but to perform a second account failover and then reconfigure that for GRS, reseeding data again. Think about the time and cost that that involves to do. We have to read all of the objects. We have to transfer that between the regions. We have to write that to the regions. And every time we do the failover, our primary region is lost. So did you know that Azure Storage will automatically check the integrity of your objects through CRC checks when all the data is written, and by performing integrity checking on all those reads and writes through the network using network traffic checksums? So at least Azure is making sure that when it does do these copies, it has put provisions in place to make sure that the data has been verified. Saves us needing to read from that secondary region when we've just looked at all of those limitations to the product. And did you know that if you use Azure's immutability functionality, you can't trigger a storage account failover? Only Microsoft can perform this when they deem that an event warrants a storage account failover. And finally, did you know that Microsoft won't let you define a secondary data region? So be sure to consider any data residency requirements you might have before your data ends up in a country you weren't anticipating. So that's it for Microsoft, but of course, it's the big 3, as Hin said earlier. So let's look now at the Google Cloud Platform. Their geo-redundant offerings are called dual region, or DR, and multi-region, MR. Google's approach to geo-redundancy is far more flexible than AWS and especially Azure. Google lets you define which regions you wish to partake in a dual region offering. Within dual region, Google lets you specify the 2 regions within a geographic area, such as London and Madrid within Europe, or Dallas and Las Vegas within the US. Google will then handle all of the object replication necessary between those 2 regions for you. A multi-region is similar, but this enables Google to provision your data within even more regions. You instead target a geographical area such as Europe, and Google places the data where it makes sense to them. So on the surface, this makes multi-region sound like the superior solution, but there are some key constraints that we'll get to. Firstly, multi-region is geo-redundant, exactly the same as dual region, but where things get messy is that the data is flexibly stored, and that is determined by Google. This leads you to latency imbalances and egress charges that always apply when reading data, even if it's a read within the same region. Typically with AWS and Azure, if we're reading within the same region, we don't have egress bandwidth, but we always will for multi-region. Because of this, Google don't recommend you use multi-region for backup and archive data, but we'll explore it all the same, as some people might be using this for their backup data. And a key reason behind this rationale is that regional storage, so non-geo-redundant storage, is cheapest. Then multi-region storage is more expensive, but dual region traffic is the most expensive. This is because Google are choosing where to store your data for your benefits. It will take into account where your reads are taking place from, but it's also for their own capacity optimizations. Now that we've clarified these two different regions, I'll get into some of the did you knows. Firstly, did you know that whilst both dual region and multi-region provide asynchronous replication to a secondary copy of data, only dual region offers a replication with an SLA. By default, both of these options won't have an SLA, and Google's target is to copy 99.9% of the objects within an hour. However, with dual region, you have the option to pay an uplift on the replication service, and they call it turbo replication. This is a financially backed SLA, just like we saw with AWS with their S3 RTC, and it drops the replication time to 15 minutes. And this isn't for 99.9% of your objects anymore, it's for all of them. Now, did you know that dual region storage has a higher throughput defined versus multi-region? Even a single region has a higher throughput capability versus multi-region. Multi-region cloud storage will offer 50 gigabits per second per region per project. That's the way that Google refer to their different groups of resources, whilst regional and dual, regional and dual region will offer 200 gigabits per second per region per project. What's more is you can request higher throughput from Google on one or both regions if you wish. Should you need that level of throughput, most people won't. Next, did you know that Google will ensure whether you use geo redundant storage or regional storage, all of your data will always be stored across a minimum of 2 zones within a region to protect against localized outages. If we compare that to Azure again, where we saw LRS and ZRS, this is ZRS effectively, but for 2 zones. And finally, did you know that Google's goal for availability is what they call RTO equals 0, meaning that if there's a zonal or regional failure, you don't need to change storage paths or perform any failover or failback of your geolocations. Google will automatically serve the secondary region in the event a failover is necessary, and they'll fail back exactly the same. Nothing that we saw within Azure again there, storage account failovers, reseeding data, no, transparent. So I've just talked an awful lot about object storage. And after that, you might be thinking, I'm completely pro backup copies, completely anti-geo redundancy, and I'm really not. They both have their place, and I want to take some time now to look at the other side of the coin, backup copies. By now, we can clearly understand some of the disadvantages to object storage, which when compared to backup copies do give us some advantages. These include Veeam having complete visibility into a backup copy status, as we're not committing any asynchronous data to secondary regions. We also get the benefit of choosing whichever secondary region we wish for our data if we use a backup copy. But this again comes with some considerations, namely whether we can use our previous backup as a source or if we need to create an entirely new backup from the production data. For example, if I wanted to back up within Azure's UK South region and have another backup within Azure's US East region, I could perform a backup copy as they use the same object storage type. However, if I wanted a backup copy between Azure's UK South region and then Google's Europe West 2, as a second backup copy, I need individual backup chains from a source data set, as Veeam doesn't always support copying objects between these different platforms. I say it doesn't always support it because some products, such as Veeam Backup for Microsoft 365, do support copying between these different object storage. It all depends on what that data looks like when it sits within the object storage. Now, utilizing backup copies can enable other functionalities within Veeam. We're not just talking about monitoring, but for example, if you're working with Veeam Backup for Microsoft 365, only backup copies can be enabled with immutability. So a Geo Redundant object storage offering as the primary backup wouldn't benefit from immutability, even if Veeam integrated with the immutability features when it's used as a backup copy target. Moving on to some of the key disadvantages of backup copies is the increased data management involved. You have to maintain multiple backup copy jobs to achieve your required data resiliency versus native geo-redundant storage options. This can also lead to a creeping increase in costs versus native availability zones. For example, when I performed testing of a 1 terabyte backup using UK South and UK West with GRS versus availability zones, the costs can start to creep up significantly. This will typically vary on a data center distance. For example, copying to another European data center didn't increase my bandwidth costs at all versus writing to UK West, but writing over to America immediately doubled my bandwidth costs. So your mileage will vary depending on what you're trying to achieve. But another key disadvantage to these backup copies is that you are required to bring your own compute and bandwidth resources into the equation. For example, if I wanted to copy data from Azure UK South to Azure UK West via a backup copy, I need to fetch the data from my source container via some form of compute, such as a virtual machine, and over a network from the container to that virtual machine, whether hosted within Azure or out of the cloud entirely. The virtual machine then needs to send the data onto its own destination, performing any error checking validations as necessary. And this can reduce efficiency versus native geo redundancy, and it increases the time for backup copies to exist within a secondary region by quite a considerable amount. If we consider those SLAs we talked about earlier, Google's turbo replication, having all of those objects copied within 15 minutes. If we have to pull all of that data manually out of a region and put it into another region, we would have to wait for our backup to finish and then perform a backup copy. Is your backup going to finish and be able to complete a backup copy in 15 minutes? Probably not. So that RTO time increases for that secondary region. And again, when we're talking about compute and bandwidth, well, those have costs associated with them. So again, echoing my previous point, those costs will continue to increase versus native. When we're using these native solutions, the management backplane is handling the compute and the bandwidth. It all gets billed as part of the service versus us having to bring our own kit. So moving on from that, I hope this has provided some insights into different storage options available. And I hope this is shining a light on some of the lesser known details when working with object storage. My goal here wasn't to lead you to a single answer, as I don't truly believe that there is one. Just different configurations that best suit different scenarios. And the more we know about these, the better we can enable ourselves. So, were there any questions from that session? I don't know, Hin, if you saw if there were any there. It looks like there haven't been any, but open call now. Any questions about this session or taking it wider? Any questions from the community regarding the Cloud City Veeam user group? At this point, feel free to come off mute if you want to just open it or chat. Don't mind. The floor's open. I've either bored everyone to sleep or I've managed to answer everything so succinctly that there wasn't a single doubt in anyone's mind. And I'm inclined to think it was the former, not the latter. There we go then. So give everyone a minute. Just while we're waiting, Hin,
Yeah, no,
that
was a great presentation, Michael. There's again, it just highlighted a lot of the things that there's a lot more considerations when working in the cloud, because it's we're dealing with different ways that I mean, as you pointed out, the three those big three approach things a little differently, and there's things that are not obviously documented, right? So those are all things that we need to think about in terms of what's the best data protection solution for each use case, right? And like I said, there are going to be many paths to the same summit, right? There's going to be different ways to approach things, and I'm looking forward to that. I really hope that there will be a lot more discussion about all of these different from the field experiences that people have, right? So
Yeah, definitely. And as you mentioned there, with it being lesser known, when these products come together, you've got the salespeople that want to talk about the features, then you've got the technical documentation in the background saying, well, this is actually how we enable it, and here's some of the limitations. And then again, if you want any kind of SLA against a service, well, then you've got your legal and financial impacts that these services are going to be very cautious about.
yeah.
Microsoft saying, yep, everything needs to, everything should be copied within an hour, should be 15 minutes, but we're not pinning ourselves to anything there because they know that when they have maximum file sizes, if you think about uploading a 5 terabyte object, for example, yes, in backups, we're not doing that. We're splitting it out into many smaller objects, but you've then still got to copy those 5 terabytes. So it's easy to think, oh, well, that's just a bit of laziness on their part. But just like our use cases can be so different with object storage, so are all the customers using object storage not for backup, but completely different purposes.
Mm-hmm.
Azure storage, you've got services such as Azure Files that sit on there. It's a
Yeah.
completely different use case to backup. So
Mm-hmm.
yeah, when we start to see that, things really start to become messy, and I can ultimately understand why these cloud vendors don't want to tie their hands too much, but it's our job as techies to pull that information into the light and say to people, this is what we have found. This is the whole purpose of this Cloud City user group, share
Mm-hmm.
our experiences.
Yeah.
So there we go. I'm going to say that no one else has got a question there. So final call for any questions, anyone? Well, in which case then, look, everyone, thank you for joining us today. If you had a question and you didn't want to ask it publicly, please either message myself or Hin privately, and we'd be glad to chat. Likewise, if we did miss your question, please just post in the community. And look, we hope to see you all in Cloud City soon.
Yes, absolutely. Thanks for all your time, everyone.